Chapter 8, Section 1, Part 2 is only a couple slides because we're actually going to work on adding and subtracting these polynomials. We're just going to jump right in here with some word problems. A researcher studied the number of overnight stays in U.S. National Park Service campgrounds and in the backcountry of the National Park System over a 5-year period. The researcher models the results in thousands with the following polynomials. Campgrounds were negative 7.1x squared minus 180x plus 5800. The backcountry was 21x squared minus 140x plus 1900. In each polynomial, x equals 0 corresponds to the first year in the 5-year period. What polynomial models the total number of overnight stays in both campgrounds and backcountry? Okay, so these are our keywords. Total number in both. That just means that I'm adding these two things together. Okay, there are two different ways that we can do this. We can line them up like we learned how to add in elementary school, which is what we're going to try first. Okay, we are going to try taking the negative 7.1x to the second minus 180x plus 5800, and we are going to add on to that 21x to the second minus 140x plus 1900. Okay, what's really important here is that you make sure that you line up like terms. Okay, so the first thing we're going to do is we are going to add together our x squareds. So if I have a 21 and a negative 7.1, that actually leaves me with 13.9 x squareds. Okay, this next one, I'm going to add up just my x's. I have negative 180 plus negative 140, which gives me a negative 320x. And then last but not least, we're going to add together 5800 plus 1900, which gives us a positive 7700. That's actually your final answer for this. Now, if you want to do the second method, we can just line them all up straight and combine like terms, which is basically what we did here. You can decide which method you like better. You can just look at it and know we're combining these, and we're combining those. Okay. A nutritionist studied the U.S. consumption of carrots and celery and of broccoli over a 6-year period. The nutritionist modeled the results in millions of pounds with the following polynomials. What polynomial models the total number of pounds in millions of carrots, celery, and broccoli consumed during the 6-year period? So total number, we're just adding these up. Okay, so I'm just going to circle our like terms so you can kind of see what I was talking about from before. If I have 14x squareds and negative 12x to the thirds, ooh, those are different. Careful. Careful, careful. Okay, I don't have any more x to the thirds, so actually those get to stay how they are. Negative 12x to the thirds. Now, my x squareds, I have 106 and I have 14. That leaves me with a positive 120x squareds. Okay, done. Then I have negative 241x's and another negative 14x's. Combined would be negative 255x's. And then last but not least, I have 1545 plus 4477 gives me a positive 6022. It's your final answer in polynomial form. Okay, now we're going to switch to subtracting. We need a simpler form, which just means that I need to simplify anything I can, so I'm actually going to subtract these. If you think about it, this minus, we can either distribute this minus and then add it, or we can just know that we're actually subtracting them. So when I look at my like terms, I have 1x to the third, and I'm subtracting 7x to the thirds. Okay, so that leaves me with a negative 6x to the third. Then I have negative 3x squared, and I'm subtracting 5x squared. So now I'm all the way at negative 8x squared. Last but not least, I have this 5x nothing to match it on the other side, so I just keep the 5x. And then I have this first polynomial minus a negative 12. When I have minus a negative, that turns to a positive. So that's your final answer. This might be another good one for you to line up. So I have x to the third minus 3x squared plus 5x. And I'm subtracting 7x to the third plus 5x squared. I don't have anything right here, so I'm going to leave a gap, and then I'm going to put minus 12 over here. Okay, and then I just combine like I did before. All right, the last problem for today is just one more practice problem. This would be a great place for you to stop and try it on your own if you're ready. If you are not, it's fine if you just stick around and work with me. All right, this time we're going to line them up kind of like we did last time, but we have to be careful and notice that we have some of these exponents that are not like terms. So we need to make sure that we have room for something to the third power, to the second power. These two are both to the first power, and then we have these constants. So we're going to need 4 spaces when we're making this problem. So we're going to start with the highest exponents. We're going to have negative 4m to the third. Then I have this 4m to the second, but it's in the second function, so I don't actually have anything to write next, so I need to leave a gap. Then I go to my negative m to the first and my positive 9. Okay, second problem, we know we're subtracting it, so we're going to put a subtraction and then put this in parentheses. I don't have anything to the third in my second function, so I'm leaving that, but I have 4m to the second power. I have plus m, and I have minus 12. Okay, so now I should be able to combine things, but I need to remember, be very careful, and remember that we are subtracting, so that subtraction goes to all of these numbers in the second function. So if I start here at the end, I have 9 minus a negative 12. Well, remember, if I have 9 minus negative, that's actually going to be plus. So that ends up with a positive 21. And I do want to write the plus because that will get me my symbol in between that I need. Then in the next column, I have a negative 1 minus 1m, which gives me a negative 2m's. In this one, I don't have anything. This is like having a 0 minus 4m to the second power, which makes it a negative 4m to the second power. And last but not least, I have negative 4m to the third minus nothing, so this is just negative 4m to the third power. And that is my final answer. All right, so don't be afraid to ask questions if you have them, but otherwise your assignment for this section is on page 477, 8 through 22 evens, 24 through 29 all, 30 through 40 evens, and then 43 through 47 odds. Don't let that catch you. And then lesson quiz 8.1.